Welcome to the 4.2b notes. These notes are on solving particle motion problems, but we're going to use words and graphs this time. And so this example 1 says a dynamite propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height of s equals 160 t minus 16 t squared after 2 seconds, where 0 is less than or equal to t, which is less than or equal to 10. So the first question says, when is the rock at rest? One important information to remember is that something is at rest when its velocity equals 0. So that's one key piece of information I need to know. And so I go back up to this equation, problem, I'm given this equation 160t minus 6t squared. And that represents, it says it reaches a height of this equation, which means that this is the position equation. Another hint would be that s a lot of times represents position. And so this is the position function, 160t minus 16t squared. And so to find the velocity, I just take the derivative of this, and I get 160 minus 32t squared, or minus 32t. And so this is the function that represents the velocity. And if I want to figure out when the rock is at rest, I'm going to set the velocity equal to 0. So I'm going to do 0 equals 160 minus 32t. And then I'm just going to solve for t. So I'll add 32t on both sides. I'll get 32t equals 160. I'll divide 32 on both sides, and that will give me t equals, what does t equal? 160, t equals 5. And so the rock is at rest. Rock is at rest at t equals 5 seconds, because v of 5 equals 0. So you got to give a little explanation for all of these. But rock is at rest at t equals 5 seconds because the velocity of 5 equals 0. So we're going to continue this problem with a part B and a part C. So this says, same problem, describe the direction of the rock. When is it up / down? When does it change directions? So one thing to do, and anytime it says to describe like the direction of a rock, I like to make like a little line chart. And we were only concerned about this rock between 0 and 10 seconds. You would have gotten that from up here. It said where 0 is less than or equal to t, which is less than or equal to 10. And so if I want to describe the direction of the rock, one essential piece of information I need to know is that the rock can only switch direction when it's at rest, because you can't just like switch direction. Like you have to pause for like even a millisecond to switch direction. And so the only time it could switch direction is at t equals 5. And so these are going to be my intervals. This interval right here is either going to be positive or negative throughout the whole interval. This interval right here is either going to be positive or negative throughout the whole interval. But it's not going to switch between those intervals, because based on the last thing we did, we know that there's no other time in this situation where the velocity equals 0. And so all I have to do is pick some value between 0 and 5, and I'm going to use 1 because that's easy, and I'm going to plug it into our velocity equation, which we figured out in example 1a, that is 160 minus 32t. And so basically I'm concerned here, if the velocity comes out to be positive, that means that this rock is moving up. If the velocity is comes out negative, that means the rock is moving down. So if I plug in 1 here, I'm going to get 160 minus 32. And here's the thing. I don't actually care what that number is, because I'm not asked to find the velocity at 1. I'm just concerned about whether it's positive or negative. And I know that that's going to be positive. 160 minus 32 is positive. So I'm not even going to go on. Here, I'm going to pick a number between 5 and 10. I'm going to just choose 6. I'm going to do 160 minus 32 times 6. 32 times 6 is 192. And again, I know that's going to come out a negative. I'm not concerned about what the velocity at 6 is. I'm just concerned about whether it's positive or negative. And so based on this information I'm given, I know that the rock is going up between 0 and 5 seconds and down between 5 and 10. And that also just makes sense. Like if you were to propel a heavy rock, you know that this is the quadratic equation right here. And so we know it's like going up and then it's going down. So that also helps us with the direction of the rock, but I'm going to erase that right there. So now I have to give like a little explanation. And so I'm going to say the rock is moving up between 0 is less than t, which is less than 5, because velocity of t is greater than 0 on that interval. It changes directions at t equals 5 and goes down between 5 is less than 2, which is less than 10, because velocity is less than 0. Okay, one more question that this is going to ask us is, at t equals 4, is the rock speeding up or slowing down, or neither? So if you're asked that question, you need to consider the acceleration and you need to consider the velocity, because an object is speeding up if the acceleration and velocity have the same sign, and then an object is slowing down if they have different signs. So I already know that the velocity equation is this, 160 minus 32t, and so if I want to figure out the velocity at 4, I'm just going to plug that into the equation. And that's going to equal, if I plug that in a calculator, that's negative 30 or positive 32 feet per second. So that's positive. And then I need the acceleration equation. So that's just the derivative of velocity, and that'll be negative 32. And so that basically means that at 4, the acceleration is negative 32 feet per second squared. And so those do not match. And so at t equals 4, the rock is slowing down because velocity at 4 is greater than 0 and acceleration at 4 is less than 0. Awesome. So those are word problems. We're going to go into some graphs, and graphs can sometimes be a little trickier, but I also think that they're really helpful in understanding what are we actually doing here. So this says an object is moving along a line. The following graph gives its position. So every time you get one of these problems, just make sure you understand which graph are you given. Are you given the position, the velocity, or the acceleration graph? So the following graph gives its position relative to its starting point over time. For each point on the line, is the object moving forward, backwards, or neither? So I'm going to call this point A, and I'm going to give this point C, D, right? So the idea of, is an object moving forward, backwards, or neither? Well, that's a question that we answer with the velocity, but we're given the position graph right here. And so you might be like, what do I do? Well, this is the best part of all, and that is, if you guys remember, the derivative, the slope of the tangent of tangent is the derivative. So how does that apply here? Well, the position, the derivative position is velocity. So the slope of the tangent of position of all these points, slope of tangent on position is then going to be velocity, okay? So the slope of the tangent on the position is therefore going to be the velocity, because the derivative position is velocity, and so if the slope of the tangent is the derivative, the slope of the tangent on position is going to be velocity. And so what I'm going to do for here is, at all these points, I am going to just draw a tangent line real quickly. And again, I'm only not really concerned about what the velocity is, I'm just concerned about its sign. So the slope of the tangent line right here is negative. And so I'm going to say that this is, let's say that is, it's not 1. I'm just going to say like 0.75. So I'm going to say velocity at 0.75 is greater than 0. So it's moving forward because the velocity is greater than 0 there. And that's just, that's opposite. Okay, the slope of that tangent line is negative. So that means the velocity at 0.75 is less than 0. And so it's moving backwards. And if I draw a slope of the tangent, or if I draw a tangent line at B to model this curve, that's just going to be a horizontal line. And so V of 4 equals 0. So neither. It's at rest. If I draw the slope, if I draw a tangent line here, I notice that the slope at 5 is positive. So the derivative at 5 is positive. And so this is going to be moving forward. And then again, the tangent line at D is a horizontal line. And so the slope at 8 equals 0. And so neither. That's how you would do these problems. So the next question is like essentially the same question. It says an object is moving along a line. The graph gives its position relative to its starting point over time. Is the object moving forward, backwards, or neither? So feel free to try these on your own. I'm going to write their answers out, but feel free to try them on your own real quick. So you can either just like ignore me or pause it. but I'm just going to go through these answers. So all of the tangent lines have negative slopes until you get to D. And so the velocity in all of those cases, it's the object's going to be moving backwards, because in all of those cases, the velocity is 0 because the slope of the tangent lines are negative. So that's the answer to those ones. And then except for the last one, that's a horizontal line. And so neither is happening here. And that should say V of 7 right here. So we're going to go into another example real quick, and this is now the velocity function. So this is the velocity function, not position. So again, just like take into account if you see one of these problems, like what kind of problem are you looking at? And this says an object is moving along a line. The following graph gives its velocity over time. For each point on the line, is the object speeding up, slowing down, or neither? So remember, if you hear the speeding up, slowing down language, you need to consider the acceleration and the velocity. And so that's something I'm going to have to keep in mind here, is I need to consider the acceleration and the velocity. And so if they're the same sign, then it's going to be speeding up. If they're different signs, it's going to be slowing down. So again, I'm going to label all of these A, B, C, or D. And so we are going to be able to tell the sign of the velocity really easily because all of these points are on the velocity function. And so, like, for example, these points right here, like this is a negative velocity. This velocity is 0. This velocity is 2. This velocity is like 3.5, 3.75. But acceleration is a little harder to find. However, in the same way that the derivative of position is velocity, the derivative of velocity acceleration. And so the slope of the tangent lines at all of these places will tell us information about the acceleration. And so let's just go through all of these. So if I look at A right here, the velocity, this is the velocity graph, the velocity is, and I'm going to say this is about 0.5, the velocity is less than 0. But if I draw this tangent line here, the slope of that line is positive. So the velocity at 0.5 is less than 0, and the acceleration is greater than 0. So this one is therefore slowing down because they have opposite signs. One is positive, one is negative. So that one is slowing down. At B, the velocity is at 0. And so if the velocity is at 0, or if either of them are at 0, you do not need to proceed because that means that it's at rest. And so I don't really care what the acceleration is because it's not moving, so it can't be speeding up or slowing down. And so that one is just neither, so you're not even concerned. At this point right here at C, V of 4 is greater than 0 because it's above the x-axis, so it's 2 right there. So I know that that's greater than 0, and then I need to take into consideration the acceleration. So I'm going to draw a tangent line. The slope of that tangent line is positive, so acceleration at 4 is greater than 0, and so this one is speeding up because they have the same sign. And then last one, D. Again, the velocity at 9 is greater than 0 because it's above the x-axis, so it's positive. And then the acceleration is also positive because that tangent line, while it's not as steep as the tangent line at C, the slope is still greater, the slope is still positive. And so acceleration at 9 is greater than 0. So this is another example of it speeding up. So that's kind of how you would do it if it's just like asking you about a specific point. This next section, these next two problems, is asking about intervals. And so these are going to be a little bit more confusing. But for this one, just keep in mind, this says an object is moving along a line. The following graph is its position. So this is position. State where the object is moving to the left, to the right, or neither. So this is the position, but it's asking about left, to the right, or neither. So we need to consider the velocity. And so as we go through all of these, we need to think of the slope of the tangent lines. And so I'm just going to go like section by section. So, and I'm going to kind of highlight the sections that change. So this section right here, if you were to do, anytime you're doing the slope, or if you're doing the tangent of a linear function, what a tangent line does is it models the curve of the line. And so there's no curve to this line. And so the tangent line is the function that you're given. There's no difference between them. And so the slope of this line right here is 0. And so between 1 and 2, this function is not moving. And so what I'm going to write here, I'm going to put this under the neither. I'm going to write 0 is less than t, which is less than 2. So the slope on that section is not moving. This next section right here, this is like one consistent piece. The slope of this line, I don't care what it is, but the slope of that line is negative. And so that one, between time 2 and 4, that particle or that object is going to be moving left. This next section right here, the slope of that line is positive. And so through that section, and when you write these sections, you always write the x values out. That's going to be moving up, or sorry, to the right. And then this last section right here, again, the slope of that part is 0. And so I'm going to put that under the neither section. So 6 is less than t, which is less than 7. So that's the answer for this section. The next problem is definitely more challenging, but you guys got this. So this one says state where the figure is speeding up, slowing down, or neither. And so this function that we're given, if you read through this, says this is the velocity. And so this one's trickier because you have to, if you're talking about speeding up, slowing down, or neither, you have to consider the velocity and the acceleration in your answer. So velocity and acceleration has to be considered. And so I'm going to kind of label my different pieces of this, but real quick, one thing I'm going to do that's different than the last time is that when I cut over into like above and below the x-axis, that's going to change. Like I'm going to highlight those as two separate sections because the velocity above the x-axis is positive and below is negative. So these are like all the different pieces I'm going to keep in mind as I go to solve this problem. So let's start in this first section right here. That first section right here, that first purple section, the velocity is positive in this section. And then, like the last one, if we want to figure out the acceleration, we just think, what's the slope of the tangent line? Well, this section right here, the slope is positive. And so the slope is positive here, which means acceleration is positive. And then the velocity is positive too because it's above the x-axis. So this section right here, from 0 to 1, my object is going to be speeding up. Let's check this next section. So here, velocity is still positive because it's the x-axis, but my slope is negative. And so that means that velocity and acceleration sign don't match. And so that section right there, my object is going to be slowing down. Next section right here, velocity is now negative, and then the slope of this line is negative. And so that's going to be speeding up because they match now. The signs match because they're both negative. So from 2 to 3, it's going to be speeding up. This section right here is easy. The velocity is negative, but acceleration is 0 because the slope of that line is 0. So from 3 to 6, my function is neither speeding up or slowing down. This section right here, velocity is negative because it is below the x-axis, but the slope of this line is positive, so acceleration is positive. Those signs don't match, so that goes under slowing down. So 6 is less than t, which is less than 7. This section right here, velocity is positive and acceleration is positive because the slope of this line is positive, so that goes under speeding up. And then our final section right here, velocity is positive, but the slope of this line is negative, and so those don't match, and so the acceleration is negative, and so it is slowing down. And that's our answer. Thank you for watching.